So what we're going to do today is we're going to continue 3.3, and we're just going to work some more examples and focus more on what do you do when you're not given the graph? How do you find intervals of increasing and decreasing and relative extrema?
Cry.
So you can cry, or what can you do? What's the first step? Find the derivative.
I like to deflect this fan to
Sure.
the side a little bit.
All right, so derivative of 1/2 x, that's 1/2. What's derivative of minus sine x? Minus cosine x. So remember, you want two things. You want to know where f prime is undefined and where f prime is 0. These are your critical numbers. We've already practiced finding critical numbers, but I do think we need to practice it a little bit more. Okay, so 1/2 minus cosine x. Where is that undefined?
Nowhere.
Nowhere. Why? Because you can take cosine of anything you want. Okay, that's why. So that thing is not undefined. So we're going to skip to the 0 part. So 0 equals 1/2 minus cosine x. And then now what? We could subtract 1/2. I think adding cosine x may make this a little bit easier. And you got to figure out cosine of what equals 1/2. Okay, one thing that we could do here is draw your quadrant here, and notice that we're in 0 to 2 pi, so we're in the first revolution. So in what quadrant is cosine positive, first of all? First one. Okay, so let's draw a triangle in the first one. Put our little theta there, adjacent's 1, hypotenuse is 2. What would that make the other side? √3. What type of triangle is this? 30, 60, 90. Okay, so then theta is 60 degrees. So what would that be in radians? Pi/3. Now there's actually another answer. So think about in what other quadrant besides quadrant 1 is cosine positive 1/2?
4.
4. What are you using to figure that out?
Right.
All students take calculus. Okay, look at all that trig. You guys remember. Good job. So we got to go the long way around. We can't just do negative pi/3. We got to go all the way around, basically doing 2 pi minus pi/3. And you are going to get 5 pi/3. Okay, these are your critical numbers. And what we need to do now is put them on a sign chart. Sign, S-I-G-N, meaning pluses and minuses. Now yesterday we put little negative infinity, a little infinity here, but in today we have some endpoints basically. So we got to start at 0, stop at 2 pi. And you need to put those on there. So on the next example, we don't have an interval. We'll go ahead and use negative infinity to infinity again. But here we have one. Now, please make sure that you put your critical numbers, whoops, as I say that, I'm doing the wrong thing. Make sure you put your critical numbers in the right order. So you have to make sure pi/3 comes before 5 pi/3, or you're going to get the wrong answer and it's going to be confusing along the way. Okay. So we had a little thing yesterday where we wrote f prime at the bottom and we wrote f at the top. And we picked a number, any number between 0 and pi/3. And we went back to the derivative. Okay, so what would be between 0 and pi/3? Pi/6. So off to the side somewhere, we need to do maybe a little bit of scratch work. We need to figure out, okay, is this thing positive or negative? Okay, well, what is cosine of pi/6? Radical 3/2. Okay, so 1 minus radical 3. Radical 3 is about 1.7. So this result, is it positive or negative? Negative. Okay, 1 minus radical 3 would be negative. So f prime is negative on this interval, which means that f is decreasing, and we showed that by drawing a little down decreasing arrow. And then you keep going. Okay, what's something in between pi over 3 and 5 pi over 3? And you have a lot of options here.
2 pi over 3.
2 pi over 3, 4 pi over 3, pi even. So now we got to kind of go off to the side. And I'm writing this down here just because it's part of scratch work. What's cosine of pi? -1. So we have 1/2 minus -1, which gives us a positive result. Now, does it make sense that if I start with a negative, the next one would be positive?
Yeah.
That's pretty much what we only saw yesterday. It doesn't have to happen that way, though. Okay, we're going to do an example at some point today where that doesn't happen. Okay, but it does happen most of the time. So now we got to pick something over here. Maybe 11 pi over 6. So that'd be like 1/2 minus cosine of 11 pi over 6. So this is also root 3 over 2. Positive. Meaning this is positive root 3 over 2. So 1/2 minus it gives us a negative result. So I'm going to erase this scratch work down here so I have more room to write my answer. Okay, so you may or may not remember this part, so I'm going to go over it again. F is, and we can abbreviate here, increasing, and we have to write the interval. So just look where your increasing arrow or arrows are. This is from from pi over 2 to 5 pi, I don't know what I'm saying, y'all. Pi over 3 to 5 pi over 3. And remember, we want to put parentheses there. And then what was our justification? Because f prime is what? Positive. Okay, once you get that sign chart, writing your answers, that should be the easy part. F is decreasing. Okay, now I have two different sections, so I have to write them out. So the first section is 0 to pi over 3. And then I'm going to union that with 5 pi over 3 to 2 pi. Because f prime is negative. Okay, so those are the intervals of increasing and decreasing. What we're going to do next is relative extrema, relative maxes or mins. So you can kind of see what the graph is doing here, at least from in this area. Graph is decreasing, then it's increasing. So what is happening at pi over 3? There is a relative min. So let's list that. Relative min. You could say f has a relative min. This was fine also. There's a relative min, and this time we say at, because it's not on an interval, it's at a specific x value. And how do we know this? Because f prime changes negative to positive. And you just look at your sign chart to figure those out. It's not something you have to memorize. And then likewise, you have a relative max at x equals 5 pi over 3. And so I'm going to finish writing this out, and I'm going to let everybody catch their breath. What do you think is the hardest part of this problem? So like, given that maybe first step is derivative, second part is finding critical numbers, third part testing, fourth part writing the answer. Testing, maybe remembering that there are multiple steps, maybe finding critical numbers, and it definitely depends on the problem. Finding critical numbers here was kind of hard because we did trig. Same thing with the evaluating. Other times that's not the harder part. Maybe finding derivative is the harder part. Okay, but it's still going to have these same 4 components. So let's look at example B. So we start where we always start. We find the derivative. Okay, this is a chain rule problem. We've done this problem many, many times, this type of problem. 2/3. I'm going over this part quickly because we've already done it. So if you're still really confused on this, I need you to come into tutoring. Okay, it's in our own best interest to clean this up. Okay, here's what I mean by that. So everybody watch up here. The 2/3, I'm going to make a fraction here. And the 2 is the top of that fraction, 3 is the bottom of that fraction. Everything after it is either going to go to the top or to the bottom. Okay, so besides this 2 on top of the 2/3, the only other thing on the top is this 2x. Okay, because a negative exponent means move it to the denominator. So I have a 2 times a 2x. That makes a 4x in the numerator. And in the denominator, I have that 3 from the 2/3, and I have the x squared minus 4. Because it's a negative power, it goes in the denominator. What is to the 1/3 power the same as? The cubed root. So that's actually how I'm going to write it, because I think it's going to make the next thing we do easier if we go ahead, and let me rewrite these 3's just a little bit, make it a little bit clearer. So this is the cubed root, and there's a 3 times it in front. Okay, so I want to know where this thing is 0 and where this thing is undefined. Now, when you have a fraction, basically that means where is the top equal to 0 and where is the bottom equal to 0. If the top of a fraction is equal to 0, the whole thing is 0. What if the bottom is 0? What does that get you? Undefined. So we're covering both of the things we have to cover. So instead of like making this a big algebra mess, let's just think logically. What x value makes the top 0? X equals what? 0. You don't need to solve a lengthy equation to figure that out, if you've rewritten it this way. It wasn't as obvious at the beginning. Okay, now let's look at the bottom. Okay, you can cube root anything, a positive and a negative. What we are really not sure about is where x squared minus 4 is 0. So what value of x makes the denominator 0? 2, and there's one more, -2. Because if I plug in -2, I square it, I get 4. 4 minus 4 is still 0. So be careful about that, but notice that we didn't need to solve a lot of equations. We can really think about this logically, and it works out. So I have 3 critical numbers on this problem. So now we need to place them on a sign chart. Now I don't have an interval that they're telling me to stay within, so I go ahead and put -infinity to infinity. And when you write your critical numbers, please make sure you put them in the correct order. Okay, we're like a big family in here, right? We like each other, so let's split up the work. Okay, if your birthday's in January, February, or March, you get this section. Okay, right here. If your birthday's April, May, or June, you get this section. July, August, September, you get between 0 and 2. October, November, December, you get 2 to infinity. Okay, first section, what'd you guys get? Negative. Should have gotten a negative. That means F is decreasing on that interval. What about people in here? So think about it this way. -1. Is that what y'all plugged in? If you plug a -1 into the top, you get a negative, right? What happens when you plug -1 into the bottom? You also get a negative. Because -1 squared is 1. 1 minus 4 is -3. You cube root that, you still get a negative. So a negative divided by a negative is a positive. That's the harder one. People all day today have been having a hard time with that one. Okay, what about the next group? 0 to 2. What'd you guys get? You should have gotten a negative because this time if you plug in a 1, say the top will be positive, but the bottom will be negative. So in this type of problem, really the plugging in, I think, is the hardest part. Okay, what about the last group? Positive. Now, we see again, we have this alternating thing happen. And that's pretty standard. It doesn't always happen that way, but it's pretty common. All right, so let's write our answer. Okay, F is increasing on, and then we could say -2 to 0, union 2 to infinity. Don't forget, because F prime is positive. And then what I would like for you to do is to go ahead and write the other 3 statements. And try it on your own, and then check up at the board when you're done, see if you got the same thing I got. All right. So what if I gave you a sign chart and I just asked you to write the statements? How do you feel about that? Would that be easier than doing all the other parts? Yeah. So sometimes there might be a question like that. Okay. Now, so far, we've definitely seen this alternate. I've already warned you that it doesn't always happen that way. So I still want you guys checking every single section each time. Okay, so I'm going to move this up. You can still kind of see the written out, but we're going to start C. First step, find the derivative. What are you going to do to find this derivative? What rule? Quotient. You could technically go ahead and divide each thing by x squared, make it look like a polynomial, and do it that way. I really don't think that's much easier in this case, so I'll go ahead and go with what you guys, and let's do quotient rule. So derivative of the top, that would be 4x cubed times the bottom minus top times derivative of the bottom, all over the bottom squared. Okay, what next? Yeah, simplify, clean it up. 4x cubed times x squared, that's going to be 4x to the 5th. And what I'm going to do here on this next one is I'm going to distribute the 2x and distribute the negative. So I'm going to do like minus x to the 4th times 2x. That's going to be minus 2x to the 5th. And then again, minus 1 times 2x. That would be minus 2x. And in the bottom, squared is to the 4th. Okay, I got a couple of x to the 5th, so I can combine those. And really simplifying here is just going to make the next step easier, so you want to do it. And even if you can factor, you want to do that. So what can I factor out of the numerator? 2x. So I would have x to the 4th minus 1. And you can actually keep going. You can factor x to the 4th minus 1 into difference of squares. I'm not going to do that, but you could keep going there. I have it broken down enough to where I can figure out what I need to figure out, which is where does the top equal 0? That would be where the whole derivative equals 0. And where does the bottom equal 0? That would be where the derivative is undefined. And the whole reason we're doing this is so we can figure out what are our critical numbers. So what do you guys think? What's one critical number? 0. That's true for the top and the bottom. What else? 1, because 1 to the 4th minus 1, that makes a 0. And there's one more. Negative 1. For very similar reason as to what we did before. So then we make our sign chart. One thing that I'm going to say that I think might help speed along this whole plugging in number business is when you look at something like this, and I circled the factored one because that's the easiest one to work with, x to the 4th is always going to be what? Positive. So don't even waste your time plugging a number into the denominator. Just look at the numerator. So if you take a number like negative 2, okay, 2 times negative 2, that would be a negative. And what about negative 2 to the 4th minus 1? That would be positive. So a negative times a positive would be negative. And if you had to guess, what would you guess would happen next? And that would be correct. Always, it would be good to check though. So the way we could check is plugging in a negative 1/2. That would give us a negative. And then negative 1/2 to the 4th would be a pretty small number. Minus 1, that'd be a negative. So negative times a negative would make a positive. And just for purposes of I want to get to other examples, this is what happens to the rest of this problem. Okay. So I'm not going to write down the answers. I feel like you guys are pretty good at that. It's coming up with the chart. That's, I think, kind of the hardest part right now. So let's continue on. We're going to skip D. We may come back to that. We may not. But for right now, let's just skip to E. Okay, first step, find that derivative. X times e to the x. Go for it. Okay, this is what I got. can we factor this or clean it up a little bit? What could we do? What could we factor out? E to the x, and we would be left with a 1 in the first group and an x in the second group. So we need to consider, where does this thing equal 0 and where this thing is undefined. I want you to write something off to the side. E to the x is always positive, and that is a great thing in life. E to the x is always positive. So that means e to the x is always defined. It's always positive. Okay, so there's, e to the x is not undefined. 1 plus x we know is not undefined, so I can skip straight to the 0 part. And here's another reason why e to the x is positive is great. If e to the x is always positive, can it equal 0? Nope. So there's no critical number from that part. So our one and only critical number is -1. Okay, let's go ahead and make our sign chart. -infinity to infinity. Just our single critical number there. Here's another reason e to the x is always positive is nice. When you start plugging things in, if e to the x is always positive, you don't even have to worry about actually computing that. Like, don't take time going, oh, is e to the -2? What is that? E to anything is positive. So all you really got to plug into is 1 plus x. So we get a negative for this section. So f is decreasing. What do we get for the right? A positive. So I've told you guys before, E is for easy. Okay, if you can remember a few things about E, then really these problems end up being easier than most other problems. Okay, and again, I'm not going to finish writing the answer there because I think we've had enough of that. We did skip one, so we're going to add one. However, before you get upset about this, I'm going to give you the derivative. I'm not even going to make you find the derivative. I'm going to give you the derivative, and I'm going to give it to you in factored form. So we already did that. What else do we need to do, though? Find the critical numbers. So where is this thing undefined? It's defined everywhere. There's no denominator, there's no square root, there's nothing weird, but we do need to set it equal to 0. Some of you were giving me those answers. And so we do have critical numbers from the derivative being 0, not from the derivative being undefined. And since this is already factored, that makes this part easy. X equals 1, x equals -2. You may be thinking, why did you give us this problem? This seems pretty easy. I did it to prove a point. Okay, I want you to go ahead and complete this sign chart on your own. And if something weird happens, that's okay. It's supposed to happen. If nothing weird happens, check your work. Okay, I'm getting minus plus plus. Do we need to go over one of these? So I told you something weird was going to happen. This is the first time we've seen where it didn't alternate, go back and forth. This isn't going to just happen like out of the blue. This is going to happen at numbers that give you multiplicity roots, basically. Do you guys, or even multiplicity? Do you guys remember double roots or even multiplicity? What you've seen this as is instead of a graph crossing the x-axis, what it did instead is it bounced off. Yeah, tangent, the radii t is tangent together. Or if you had a vertical asymptote, these things, it would be like the same behavior on both sides. So the whole thing that causes that is what's causing what we're doing. Okay, I'm going to erase that because that didn't really have to do with what we're doing, but it's the same idea. Okay, that right there, because what gave me the 1 had an even power, I knew that this was going to be like this. So we're kind of developing some patterns here. So do we have a relative min? Yes, we have a relative min at x equals -2. And just for time, I'm not going to write the because statements. Do we have a relative max? We don't. So what is happening at x equals 1? If I said, what is happening at x equals 1, you would say, nothing. I mean, it's not a relative min or a relative max. It is neither. I wouldn't really say nothing. Something is happening. I'm going to show you this graph. And if you were writing the increasing interval, you would have to write it like this, -2 to 1, and then 1 to infinity. You cannot just go, oh, plus all the way through -2 to infinity. You have to skip over 1, because remember our because was because f prime was positive. F prime is not positive at x equals 1. It's 0. Okay? This is what this graph looks like. It's coming down. There's a normal relative min, and then it levels off. But instead of turning back down, it just keeps going right back up. And that right there is like a saddle point. I don't want to say like a saddle point. That's a name that some people call it. It's a place where the graph levels off, but not as a max or min. Okay?